What is Bayesian statistics? The table game. Alice and Bob are playing a game in which the first person to get to 6 points wins. The way each point is decided is a little strange. The casino has a pool table that Alice and Bob can't see. Before the game begins, the casino rolls initial ball onto the table, which comes to rest at a completely random position, which the casino marks. Then each point is decided by the casino rolling another ball onto the table randomly. If it comes to rest to the left of the initial mark, Alice wins the point. To the right of the mark, Bob wins the point. The casino reveals nothing to Alice and Bob except who won each point. Clearly, the probability that Alice wins a point is the fraction of the table to the left of the mark. Call this probability P. And Bob's probability of winning a point is 1 minus P. Because the casino rolled the initial ball to a random position before any points were decided, every value of P was equally probable. The mark is only set once per game, so P is the same for every point. Imagine Alice is already winning 5 points to 3, and now she bets Bob that she's going to win. What are fair betting odds for Alice to offer Bob? That is, what is the expected probability that Alice will win? If P were known, this would be easy, because Alice just needs one more point to win. Bob only wins the game if he takes the next 3 points in a row. The probability of this is 1 minus P to the third power. Alice will win on any other outcome, so the probability of her winning is 1 minus P cubed. If Alice knew P, it would be easy for her to calculate fair odds. For instance, if the mark were exactly in the middle of the table, or if this were the coin game where points were decided by flipping a fair coin, P would be 0.5. The probability that Bob would win would be 1 minus 0.5 cubed, or 1/8. The probability that Alice would win would be 7/8. Fair odds would be 7 to 1. Inferring P from the data. The problem is that Alice and Bob don't know P. The very fact that Alice is ahead 5 to 3 is evidence that the unknown position of the mark is probably giving Alice an advantage, but the numbers are small, and she can't be sure. Maybe the mark is in Bob's favor and he's just been unlucky so far. This sets up a scientific inference problem in a microcosm. We have a limited amount of data. Alice is winning 5 to 3. We are interested in inferring an unknown hypothesis, the value of P. We want to use this inference to predict future events. How probable is that Alice will win? One approach would be to use the maximum likelihood estimate of the unknown parameter P. This is the frequency at which Alice has won so far, 5 to 8. From this, we estimate that Bob's probability of winning is 3 to 8 cubed, which is equal to 27 divided by 512, and Alice's probability of winning is 485 divided by 512. Fair odds would be about 18 to 1, but as we'll see, this is way off.